Are you sure?
I got 9.
Someone No. It was good. Thank you.
All right. That's half the homework.
No,
It's exactly half.
I know it's exactly half, and I did one of them, didn't I? Yes. Last time I did number 8. Why is number 8 up there when I did it?
Oh.
So we are not doing number 8 because I did it last time.
Oh, yeah, I did.
Oh, actually, no, I do have that in my notes.
Okay, number 5. dy dx is equal. You have to get good at this because of the 6 free response questions you're going to get on the AP exam. This is one of them right here. And if you don't put the plus c, you lose half the points already. That's y equal 1 when x equals 0. Okay, how do you solve a differential equation when you have both x's and y's in it?
You put one each side.
Separate the variables. Put all the y's on the left with the dy, and put all the x's on the right with the dx. Just for doing that, you get 1 point, you know. Now you integrate both sides. Natural log absolute value y plus 5. Yeah?
Yeah.
Plus c equal 1/2 x squared plus 2x plus c. Mush the two c's together into just 1 plus c. You just got yourself another point. In fact, you might have got the 2 more points because you did 2 antiderivatives. Now you got to figure out the value of c. So y equal 1. So if I plug in 1 for y and 0 for x here and here, what do you get? Natural log 6 equals 0 plus 0 plus c. We just figured out c. So natural log y plus 5 is equal to 1/2 x squared plus 2x plus natural log 6. Hey, what happened to the absolute value?
Yeah.
We went over this last time. Because remember, if the inside is positive, you leave it alone. If the inside is negative, you negate it. So when I plugged in the initial condition of 1 here, is 1 plus 5 positive or negative?
Positive.
It's positive, so you don't need to put the absolute value. In fact, in this particular problem, you have to decide whether you're going to either leave it alone or negate it, and that is determined by the initial condition. So if you plug in the initial condition and it comes out positive, then you leave it alone. If you plug it in and it comes out negative, then you negate it. That's how it works. Okay, now all you have to do is solve for y now. How do we get rid of this ln here? You e both sides. E to the natural log banana is banana. And then, now, like I told you before, if this was if it was free response, I'm not sure if they're going to give you full points for that. You have to simplify this to 6e to the 1/2 x squared plus 2x. What? Remember what we did last week? Why is this the same thing as that?
E to the ln.
Yeah, because this is the same thing as e to the 1/2 x squared plus 2x times e to the natural log 6. Right? Because when you multiply things, you add the exponents. And e to the natural log 6 is 6. Now I can guarantee you, if this was a multiple choice question, they're going to have a 6 plus there as one of the choices. But you know better, right? I hope. So the final step is finally get rid of this 5, so just subtract 5 from both sides, so your final answer is going to be 6. E to the 1/2 x squared plus 2x minus 5. Box that. That's the answer. And like I told you last week, the only step that required calculus was just going from here to here, finding the antiderivative. Everything else is algebra. All right, number 6. What do we got? Boo. dy. You guys just put it up here because it's even. Cosine squared y. Y equals 0 when x equals 0. Okay, Okay, first step, separate the variables. So bring this on this side, so you gotta divide it. dy over cosine squared y is equal to dx. Hey, you got 1 point for that. Integrate both sides. Now, how the heck do you integrate the left side? Well, yeah, isn't that the same thing as just integral of secant squared y dy? 1 over cosine is secant. Right? Oh, so secant squared is on the list.
Time work.
Tangent y is plus c equals x plus c, and then you mush the two c's together. Now plug in the initial condition. If I plug in 0 here and 0 there, they're both 0. I don't like that. So we just figured out c is 0. Yeah, I really don't like that. You know why I don't like making c come out to 0? Because then the people who forget to put the plus c don't get the problem, right? So don't worry, on my quizzes and tests, don't worry, c will not be 0. So tangent y equal x plus 0. How do you solve for y? Divide both sides by tan. No! You tan inverse both sides. Box that, that's the answer. Number 7. Oy! Somebody's gonna pay for that. 7. No, dy dx equals cosine x times e to the y plus sine x. Okay, how the heck am I gonna separate these variables? That's why I did that. That's why I did number 8 last week, to help you on this kind of stuff here. But of course, if you don't remember it or write it down, it's hard, huh? What do you do with something that looks like this?
E to the y.
E to the y times e to the sine x. And again, when you multiply things, you add the exponents. So now we can separate the variables. So when you bring this on this side, you gotta divide it. So e to the y equals cosine x e to the sine x. Okay, you got 1 point. Oh yeah, dx. Integrate both sides. Okay, who's got the left side?
Y.
Huh?
Y. No.
But why? The left side? No. No.
Negative y.
We did this. We did number 8 last week. Negative e to the negative y. Word.
Oh, makes sense.
Isn't this the same thing as e to the negative y? So is the antiderivative of e to the box just e to the box? No, I left the space in the front to adjust for the derivative of box. What are you guys thinking? Natural log e to the y?
Yeah.
Then where's the absolute value? So you're wrong on 2 counts
But
there.
isn't e to the something always positive? So you don't need absolute.
Oh. But anyway, that's wrong. Okay, that's actually correct. But the antiderivative, just because you see 1 over something, that doesn't mean it's natural log. What about this then? 1 over root 1 minus x squared dx. No, but by your guys' reasoning, it's natural log root 1 minus x squared plus c. By your reasoning. No! Just because it's 1 over, that doesn't mean it's natural log. 1 over x to the first power, that's natural log. This is e to the negative y. I guess I know which one I need to put on the test then, yeah? Equals, and wait a minute, time out. What was the initial conditions of this one?
Y equals 0, x.
Y equals 0 when x equals 0. Y equals 0 when x equals 0. Isn't that? I'm trying to think, no, that doesn't come up here, so don't worry about it. Okay, now how do you integrate this right side over here?
It's y equals negative 1. Sorry, my bad.
Isn't it 0?
Oh, y equals negative 1
I
now?
don't know.
I have 0.
I have 0 too, but.
What? Okay, what number is this? 7. Mine says y equals 0 when x equals 0. Oops. Well, that's what my book says. We had this problem with some other problems, like one edition has something and another edition has something else, or I don't know if it's an edition or is it the publisher. Whatever. It doesn't matter, the main thing is you know how to do the problem. Now, how do you do this integral here?
You substitute.
U substitution. U equals sine x. Du equal cosine x dx. Is it gonna work? No. So that integral is e, what the heck is this? E to the u du, which is? Well, according to your reasoning, no, never mind. It's e to the u plus c. So it's e to the u, which is sine x, and they both have a plus c, so you mush them together. So you see, if you want to get a 5 on the AP exam, you gotta at least do that. At least you get this kind of problem where you know how to do it. You cannot afford to leave those points on the table. Like if you go natural log e to the y, that's bad. That's bad. Okay, now plug in the initial condition. If I plug in 0 for y, you get -1. If I plug in 0 there, e to the 0 is 1. So cancel out, c is 0. Don't be ridiculous. C is -2. So you got negative e to the negative y equal e to the sine x minus 2. Now all that's left is one more point. Can you solve for y? For the last point. First step, how do I get rid of this negative sign?
Times by negative.
Multiply both sides by -1. So negative e to the sine x plus 2. How do I get rid of an e? You natural log both sides. Natural log of e to the gorilla is gorilla. And you have to natural log the whole side now. Don't even think about distributing it, because you can't. And then finally, how do I get rid of that negative side? Multiply both sides by -1. So your final answer is going to be y equal negative natural log of negative e to the sine x plus 2.
Why is it not absolute value?
Because we natural log both sides. We didn't do an integral. See, like here. And see some of by your guys thinking, anytime you see natural log, put absolute value. No, no. Like here, the integral of 1 over x is natural log absolute value of x plus c. That's when you put it up. If you natural log both sides, that's something totally different. You just natural log both sides. There's no absolute value. There's no absolute value on this side, right? So you just natural log both sides. And I already told you why the absolute value is there, right?
Yeah.
Somebody refresh my memory.
Because it's 0.
No.
Because the domain.
There you go, Bailey. Because the domain of this function is all real numbers except 0. So to make this one have the same domain as that, you need the absolute value. Because if you didn't have it, then the domain would be x is greater than 0. Remember Pancho?
Yeah.
Yeah.
But that's not the same domain, so that's why you need the absolute value. See, some of you going, what you talking about domain? No, here, let me ask you this. What if you didn't have that? Like, if you have this function, can you plug in -2 in for x?
Yeah.
What about this one? Can you plug in -2 for x?
Yeah.
No. Natural log of -2 is undefined. So that's why you need the absolute value. See again, what's the hard part of calculus? It's not the calculus, it's this pre-calculus stuff, right? Look, when in the 4th quarter, this is going to come up quite a bit. Whenever you have natural log something, this something got to be greater than 0, otherwise it's undefined. There's no such thing as natural log 0 or natural log of a negative number. Okay, and then finally, number 10. Because we are not doing number 8 again. No, niet, 9, EA. How do you say no in Chinese?
So what is 9?
It's no in
No in German.
Oh, wait, 9. Like 9.
9!
9.
9, Fräulein!
Oh, I see.
Okay, separate the variables. dy over root y equals, now remember the constant, you can either leave it on the right side as a 4 or bring it on the left as a 1/4.
On the right.
On the right, on the right. Okay, right there. 1 point, we're just doing that. We're just doing algebra 1. You get 1 point. Now you integrate both sides. Okay, who am I calling on for this one? And please don't Tanaka.
Yes.
And please don't say natural log root y, because I just might lose my mind.
2y to the half.
There you go, 2y to the half power. This is the same thing as y to the negative half, so you make the power 1 bigger for the reciprocal in the front. Nobody did natural log root y, yeah?
No.
Mr. Parker didn't do it.
So the top one's hard.
And then, how do you do the right side?
Integration by parts.
No.
Or the
Use
See, no,
substitution.
you're jumping ahead, okay. Again, when you see an integral, the first thing you ask yourself,
Oh
is
wait,
it
no,
on the
yeah,
list?
use it.
Second thing is use substitution. The last thing on the list for now is integration by parts. So
Really?
it's not on the list. Can I do use substitution?
Yes.
The answer is yes. So u equals.
Ln.
We still gotta know u. This is the most important technique you need on an AP exam is use substitution. And I already told you already. The integration by parts is not even on the AP exam. Remember I told you.
Wait, is
that?
that tabular?
No, none of that is on the.
That's
none of it.
UV, right?
Okay.
Huh?
just
What's
try
the
that.
UV?
Yeah, UV minus the integral of VDU and tabular, not on the AP exam.
Does it make stuff we do easy?
It's on the BC exam, but not on the AP.
Oh, yeah.
But I'm just teaching you calculus. I
Oh,
told
it's
you.
over like alpha on AP exam.
No, we gotta do chapter 8. When we finish chapter 8, then we're done.
Is chapter 8 easier than chapter 7?
If you know how to draw your pace graphs.
Can we use integration by parts on the AP exam though?
Yeah, you can, but they're not gonna give you an integral that requires integration by parts. So it's either on the list or use substitution, or you can use your calculator.
Calculator?
Yeah, you know, like options, calculus, and then integral. Remember, you can do any integral on your calculator, right?
Wait, is there a calculator part or no?
Okay,
I'm really sorry.
you can use your calculator on about 40-something% of the AP exam. You have to be able to do both. Okay, can we finish with this problem?
Yeah.
U equal natural log x, du is equal to 1 over x dx. So this integral becomes 4 on the outside. And what is that? U du. So isn't that 4 over 2 u squared plus c?
Yes.
Make the power 1 bigger. So it's 2u squared plus c, right?
Yes.
So 2, but then you gotta resubstitute back in.
I want it.
Natural log x squared plus c. Can I divide both sides by 2?
No.
Yeah, you can.
Oh wait, you can't.
Okay, some of you are scared too, so let's not.
Don't you need to solve for C?
Okay, let's solve for c. Let's solve for c. If I plug in 1 for y, the square root of 1 is 1, so you get 2 equal. Now what happens if I plug in e? Natural log e is 1, 1 squared is 1, so 2 plus c is 0. So we figured c is 0. So this is what we got. 2y to the half is equal to 2 natural log x quantity squared plus 0. Now can I divide both sides by 2? Okay. And then how do I solve for y? Square both sides. So y equal natural log x to the 4. But again, I don't like when c comes out to 0. I already told you why. Because the people who don't put it get the problem wrong. Which is unacceptable. Because on the real AP exam, if you don't put the plus c, you lose half the points. That's what's going to happen. All right, now we're going to spend another night on this section. Now that we know how to solve these differential equations, there is one special one that comes up, and you just have to memorize this one. Can I erase this now?
Yeah.
What do you mean, oh no, it's easy?
Wait, do the other classes do tabular? Other
Yeah.
maybe.
Yep. We both, whoever's teaching you, we always teach more. Because think about it. AB is a 1 semester course in college. We have like we have 3 quarters. So we got 3 quarters to learn 1 semester of college math. So that means we we slow down every once in a while, but we still have extra time, so that's why we learn extra stuff. And I told you, so when you go to college next year and take 2nd semester calculus, you're dominating. Actually, I had one student that came back from last year. She said, "Oh, Mr. Park, I took Calc 1 all over again. I wanted to boost my GPA." I guess if you want to. Okay, now there's one differential equation that's going to come up. Okay, now, and you got to be able to. Okay, here. If the This phrase is going to come up quite a few times on the AP exam. The rate of growth. So let's say you have a population of bacteria or something, or Drosophila flies. The rate of growth of these flies or the bacterial is proportional to the amount present. This is a very important thing in calculus and biology. So the rate at which the population is growing is proportional to the population. Now, how do you write that mathematically? The rate at which a population grows is proportional to the population. Now, what do you want to call the population? Y? No, normally we go with Y or P, but let's go with Y. Let's call Y the amount of Drosophila flies there are, okay? At any time t. So the rate at which this population of flies grows is, well, how do I write that mathematically? The rate at which a population grows.
Y.
dy dt. The derivative is a rate, right? Derivative is a rate. It's a rate on how the population is either growing or decaying. So the rate at which the population grows is, right, equals is, proportional.
So a constant
There you go. K, the constant of proportionality,
times the amount.
times the amount, or the population itself.
Wow.
Y, there you go. dy dt equal ky. Can everybody do that? The rate at which a population grows is proportional to the population itself. Does everybody understand this K? Okay, let's go back to Algebra 2 or Chemistry, whenever you learned this. What if your teacher said Y is directly proportional to X squared? Do you just write Y equal X squared?
K.
No, because I left the space for the K. That's called the constant of proportionality, because if you don't write it, how do you know K is 1? Couldn't K be 3 or negative, or negative 2/3 or something? Yeah, so that's why you need the constant of proportionality. Mr. Park, I don't even know what you're saying. I think we better do another one. Y is inversely proportional to X.
Or K.
Okay, K over X, inversely proportional. Come on, that's the kind they have on the SAT now, right? Okay, now, so, does everybody understand how to get this equation from here? Hey, what a surprise, it's a differential equation. We know how to solve this.
Oh yeah.
This is what you did in the last lecture. How do you solve this differential equation?
But all the t's.
Separate the variables. Put all the y's on the left with the dy. So how do I bring this y over? dy over y equal k, and then move the dt on this side. Okay, integrate both sides. Now the left side is easy. Now is the time. Natural log absolute value of y. Because that's 1 over y to the first. That's natural log. Mr. Park, where's the absolute value? No need. You know why? Because this is a population. How can a population have negative amount in it? How many flies are there? Oh, negative 17. No, a population cannot have a negative number, so that's why you don't have to worry about that. Equals, okay, here, I'm curious about this one. Who's got the right side?
Nah.
Kawahara. Aha! No. You know why? Because you guys aren't looking at this. What is your independent variable? T. This is a constant. You can throw the constant on the other side, right? See, that's why those of you who are not writing the dx, dy, dt, whatever, you're going to be sorry. Because that thing means something. It tells you what your independent variable is. It's t, not k. So, what is the antiderivative of k? kt.
Plus c.
Yeah, and they both have a plus c, so we just mush them together in 1 plus c. Okay, now, right now, we don't have an initial condition yet, so we're just going to keep on going. How do I solve for y? You e both sides. So e to the natural log banana is banana. And then we got this. But I already told you guys how to simplify that, right? Oh, we'll just go step by step. Maybe if you see it 10 times, you remember. Isn't this the same thing as e to the kt times e to the c? right? Because when you multiply, you add the, do not put plus e to the c, because I guarantee you multiple choice that answer's gonna be waiting for you. And if c is a constant, what is e raised to a constant power? It's another constant. And what do we call this constant?
C.
For those of you who are taking AP biology now. No, we don't call it c. Or if you took algebra 2 or pre-calculus, and you did
J.
exponential growth,
Chi-squared.
Oh, God.
what do we call this constant?
R.
No, why not?
Oh,
Why?
yeesh.
Oh,
Why not?
no.
That's your initial population. Why not means how much you have at the very beginning, right?
Oh, wait, we just derived that equation.
Yeah, so we just
Like had to
we just
memorize.
derived the exponential growth equation.
Oh.
See, like when you took algebra 2 and pre-calculus, your teacher told you this is it. This is the exponential growth equation. But where did it come from? It came from this. If the rate at which the population is growing is proportional to the population itself, you get exponential growth,
Yeah.
which looks like this. Whoop. Exponential growth. Now, you get exponential growth if k is positive. What if k is negative? Then you get exponential decay like this, like uranium or some radioactive substance, yeah? Okay, so what kind of problems are you gonna see tonight? Now, do you see what I did here? I did this once. You do not wanna reinvent the wheel. So on tonight's homework, what if you saw this? dy dt equal negative 4y. Am I gonna separate the variables and do the thing all over again? No. As soon as you see this differential equation, you just write down the solution already. Do not reinvent the wheel. Y equal y naught e to the
Negative.
negative 4t. Boom, there's your solution.
Y equals 1.
We studied full credit of AP.
Yeah, because they want you to memorize this one, because this is one special one that comes up a lot.
But this is just like a multiple choice, yeah?
No, sometimes it's on the free response. So you see this k here? This k is simply the coefficient of t there. So whatever number you see here, that's the coefficient of t. Do we need another example?
Yeah.
Yes.
Really?
Yeah.
Yes.
Okay, dy dt equals 7y. What is the solution to this differential equation? Y equal y naught e to the 7t.
Wait, so this is all the homework answered?
Yeah, tonight's homework. So every problem of tonight's homework is gonna use this equation here.
Yeah.
Now, sometimes on the AP exam, they change up the variables on you. Is that?
No.
So, I remember a couple years ago, they had a problem. They said the rate at which the weight of a puppy is growing is proportional to its weight. So the rate at which the puppy's weight is growing is proportional to its weight.
Y equals y naught.
So what do you immediately write on your paper?
W.
W equals W naught
E
e to the kt. Exactly right. And if you can't remember that, then you just gotta reinvent the wheel here. And then I saw on another AP exam, they made all kinds of wacky variables. dp dq is equal to kp. Is that gonna throw you off if you have different variables like that?
Equals p naught.
Okay, so what would be the solution to this differential equation without reinventing the wheel? P equals
P
P naught e to the
Q.
kq.
Oh, just kidding. Wait, it's K, I said Q.
You guys can do that, right? Look,
Oh, I see.
look. This k is that k there. This y is that y there. See, that thing there goes there. And the independent variable goes there. Do we need another example?
What's like the trickiest?
The trickiest would be this.
Oh. Let's just change it.
Yeah, it's just different variables. So that doesn't bother us because we're Iolani, right?
Yeah.
Okay, let me just do one example and we're done. So, whenever you see this tonight, don't reinvent the wheel, just write down the solution of the differential equation. Okay, now let's do something from chemistry, or if you're in AP biology, I don't know. Do you guys do carbon dating in AP biology? AP chemistry? What about regular chemistry? Okay, let me give you the half-life of
Oh, no.
carbon 14 is, I believe it's about 5730 years, right?
Yes.
For those of you who take chem, AP chem,
About.
regular chem, biology, AP biology, economics.
Oh, yes.
You guys know what carbon 14 is, right?
Yes.
Yeah.
It's an
It's
isotope.
an isotope of carbon. Carbon, and what is carbon 12?
Well,
So what does that mean? Two more somethings, eh?
Two more.
Two more neutrons?
Yeah.
Okay, I have no idea. I got a D minus in chemistry. That's passing. See, you guys go out here. It's passing. It doesn't matter. You get an A or a D, you passed it. Okay, so based on this equation, what exponential growth equation can I write? So y equals y naught e to the kt, right?
Yeah.
Now, what do I do with this information? The half-life of carbon 14 is 5730 years. That means it takes 5730 years for a given amount to decay to half.
So.
Okay, so here, y naught is how much you start with, right? What is half of that? 1/2 y naught. Where do I plug that in? I plug it in for y. And how long does it take for this to happen? 5730 years. So you plug in 5730 for t, correct? What's the only variable you have left because the y naught cancel out? K. So we use this information just to figure out what k is. Yeah, algebra, pre-cal, chemistry, whatever. Okay, how do I solve for k? How do I get rid of this e here?
Ellen.
Natural log both sides. So natural log y, and the natural log of e to the gorilla is just gorilla. And then now it's easy to solve for k. K is natural log 1/2 over 5730. Now, let me ask you this question. Is this number negative or positive?
Negative.
How do you know?
This is
Because
decay.
natural log of 1/2 is negative.
Okay, very good. Natural log 1/2 is negative, that's why, right? Mr. Park, how am I supposed to know that? Because natural log 1 is 0. So, natural log 1/2 is smaller than 0, which means it's negative.
Yay.
Okay, so k is negative, so we have exponential decay, but no, it's half-life, right? It's decaying. Okay, now that I got the value of k, so anytime you do a carbon dating problem, this is your equation. Y equal y naught e to the natural log 1/2 over 5730t. Any carbon dating problem has to use this equation. Okay, so now, what kind of questions are you going to get tonight? So, let's say you're having a barbecue in your backyard, and then your dog starts digging. And then your dog brings up a bone and
Ew.
give me that, Spot, give me that. Whoa, this bone looks funky. So is this bone from the barbecue last weekend? Or is it from an ancient civilization long ago? How do you tell? You take it to the laboratory, and then I asked somebody one time, like they worked in a lab. I said, how do you do it? They said, oh, we just put it in a machine, and the machine tells them like what the percent is. So they put it in a machine, and let's say it contains 47% of the initial amount. I don't know how they do it, but they can figure that. I don't know how it does it, but it does it. So this piece of bone contains 40% of the original amount of carbon. So now we can use that to figure out how old this bone is. So, what was the initial amount of carbon 14?
1.
Well, no, why not?
1.
What's 47% of that? 0.47, why not? Where do I plug that in? We're plugging in for what? So 0.47 y naught is equal to y naught e to the natural log 1/2 5730 t. Now y naughts cancel out, don't they always? Yeah. And then the only variable you have is t. So if you solve for t, that tells you how long it took or the age of the bone. So all you have to do is solve for t. How do I get rid of this e? Natural log both sides. Natural log 0.47. The natural log of e to the banana is banana. So how do you solve for t? You multiply by 5730. natural log of 0.47, and then you divide that by natural log 1/2. Can I cancel out the ln's? Don't you dare. This is your answer. But of course, my guess is on the AP exam, it's gonna be multiple choice section with a calculator, so you need to punch that in on your calculator.
Wait, do we have to memorize 57?
No, they probably will give you a different substance, like the half-life of
Uranium.
uranium, or plutonium, or, I think tonight's one is, I forget, polonium. I think tonight, you guys heard of polonium? Okay, somebody punch this in on your calculator, come on. I heard somebody taking it out. Chong, was it Chong?
Nope,
No, because you were sleeping.
6,241.502 years.
Point what?
502.
6,241.502 years. So this is not from your barbecue last weekend. This is from an ancient civilization long ago. So what should you do?
Sell it somewhere.
You call Bishop Museum and say, I think my house is on an ancient burial site or something. And then, would you like to buy my property for $10 million?
Yeah.
Yeah.
Look, that's what you should do. Anyway, so every problem tonight is gonna use this equation. Why not? But see, I know what you guys are gonna do. You're just gonna memorize and memorize everything, but you gotta remember the phrase where it came from. The rate, right here, the rate at which a population grows is proportional to the population. That's what you gotta remember. All right, we're done.
Hey.
So it's easy. Very mechanical. And do you know that this is the last thing we're learning in this chapter?
Yay. And it's washing.
No, but that, no, not yet. So the test is coming. Oh, I know it is. It is Friday. It's extended.
We
Hey!
also have a bio quiz today.
It's extended this week?
Yeah.
Yeah.
Wait, would you?
Oh, so we have our test. Yeah,